Hi there. This is a video on exponents, and exponents are on every single SAT. So let's start with the basic exponent rules, and then we'll go on to a few different kinds of questions. So I've got a few problems up at the top, and maybe I'll put the answers in red. All right, so when we're adding two exponents or numbers with exponents, and the bases are the same, we simply add the implied number here, like a 1 and a 1. So we're going to have x squared plus x squared is 2x squared. We treat the x squared or the exponent as kind of like a variable. So if it was like 3x plus 2x, right, we just leave the x's and add the numbers, we would get 5x, right? Okay, let's move on. If we are multiplying, then we add the exponents. So x cubed times x squared is x to the fifth. We're adding. If we're dividing, we're going to subtract the exponents. Again, as long as the bases are the same, we can do that. So x to the fifth divided by x to the second is x to the third because we have subtracted the exponents. When we have an exponent to another exponent, that's when we multiply. So x squared to the fifth is going to be x to the 10th. All right, know these basics. There are some more that will come up as we go through various questions. Okay, so the first question I want to go through is on test 1, section 3, number 14. And they give us this given information here, and then they want us to solve for x to the 8th divided by, 8 to the x divided by 2 to the y. All right, there's nothing really that we can do with this expression here. This equation is just as it is. So I suggest we move on to this division here. Now, remember what we said. If we go back up here to where we divide, I said the bases have to be the same, and then we can subtract the exponents. But here, our bases are not the same. So we need to transform one of these into the other. Now, 2 is the smallest. We can't reduce that anymore. So we're going to leave this as it is, and we're going to transform the 8 into something with a base of 2. So the question is, 2 to the what is 8? Now, I'm going to just write it over here to the side. 2 to the, let's say, x is 8. You can just plug numbers in. I mean, you might just know this. You might just know, hey, it's 3, and that's fine. But if you don't know that, you can say, well, it's not 2 to the 1, because 2 times, it's 2, 2 one time is just 2. 2 squared, I think we know that's 2 times 2. That's 4. And 2, actually, let me just say, 2 to the third is the same thing as 2 times 2 times 2, which is 8. Okay, so sometimes I forget to go, I don't know always how basic I should go. So I figured I'd just cover that. So instead of writing 8, we're going to write 2 to the third. And then the x, we still have to keep that there. Okay, now we have the proper criteria so that we can subtract our exponents. We have a base of 2, and then we get to subtract our exponents. So it's going to be 3x minus y. Well, hey now, that looks familiar, doesn't it? 3x minus y is up here. It's 12. So we can just substitute that for the 12. And 2 to the 12th is our answer, and that's A. Okay, so that's that. Now let's go to, I'm going to clear the decks here, and let's go to test 2, section 3, number 7. Okay, now as you can see, we have a somewhat similar situation with division, except it looks a little bit more complicated because we have the exponent is actually an exponent. So we have x to the a squared over x to the b squared, and that equals x to the 16th. What I like about this is that all our bases are the same. We've got x, x, and x. So that's great. All right, now that means we can proceed. I'm going to do this in a different color, right? So we can subtract our exponents because our bases are the same. So we have a squared minus b squared equals 16. And for now, I'm just going to ignore the x's so we can deal with this because this is complicated enough, right? And since all the x's are the same, well, the bases are the same, we can just add that on later if need be. Okay, so we have this, and then they also tell us in the problem that, I'll put it off to the side, a plus b equals 2. And they're asking what is the value of a minus b? Okay, so that's what we're trying to find. Now, most people do not see this right away. So I want to give you this very special SAT shortcut. This is a type of quadratic equation. And these are themselves the factors of that equation or expression. So, and I'll show you how that works. A plus b times a minus b. Now, if we FOIL this out properly, right, we get a squared minus ab plus ab minus b squared. These two cancel out and we get a squared minus b squared, right? It gets us right back up to here. Okay, excuse me. So now I'm going to rewrite it. We've got a plus b, a minus b. We know that's equal to a squared minus b squared, and we know that it's equal to 16. They told us that a plus b is 2. We know this is 2. So 2 times what is 16? Well, clearly that's 8. A minus b equals 8. Okay? I really want you to take that in. It's a fun little question. And if you know it, if you know this concept that they will often give you factors of an equation, then you can get it relatively easily. Okay, I'm going to clear the decks again, and I want to go over other kind of sample problems. I'm not referring you to any other question in the tests, but I want to give you an example. So let's say we have x to the 2/3. We didn't go over this yet in the basic rules because this is not quite a basic rule. But I want you to know this because if you know it, it's really easy. So what you do with this, if you need to transform an exponent that's a fraction, the top number, the numerator, all right, this number stays with the x. So you get x squared. The bottom number is what the root is. So you put a square root, and then you take this 3, and it becomes a cube root. Okay, so this is really good to know. Likewise, I'll just do another example. If we have x to the 3/5, this is going to be equal to, we're going to take the x, and the numerator stays with the x, and the denominator becomes the power of the root, the 5th root. Okay? All right, so take that to heart. And then I want to go over another type of question where we have negatives. This is a little bit more complicated. Let's say we have something like x to the negative 2, y to the 1/2. Okay, so we're dealing with negatives and fractions as exponents. And then x to the 1/3, y to the, let's say, -1. Okay, what do? We're going to transform this. Okay, we haven't gone over negatives yet. So let's do that. I'm going to do that over here. So let's say we have x to the -2. We want to get rid of this negative. That's nasty. The way to get rid of the negative is flip this. You're going to take the reciprocal. So the 2 still stays as the exponent. So we get x to the 2, but we're flipping it. So instead of being on the top, it's going to be on the bottom. Okay, x to the -3 is going to be 1 over x to the 3rd. Okay, so now that we know that, let's go back down to our problem. I'm going to do the answer in red. So we have x to the -2. Well, we know that's going to be 1 over x squared. Yeah? Okay, so that's the first thing. Now we can do the negative, the y to the -1. Let's just do all our negatives. And that's going to be y to the 1, or just y, but it's going to flip up to the top, right? So it's going to be a positive y. Okay. Now, generally speaking, we don't really need this one. It's what happens is if it's on the top, it goes to the bottom. If it's on the bottom, it goes to the top. Okay, so we don't really need this plus either. So now let's deal with the y to the 1/2. And remember, it's not negative, so it stays where it is. It's going to stay on the top, and that's simply going to become y to the 1. We don't really need the 1, but I'll write it in there. And it's going to be a square root, right? Because this is the power. The bottom number is the power. So that, and then if we take the x to the 1/3, that's going to be x to the 1 to, and that's, we're going to put that to the 3rd power, or the 3rd root. Okay, so we basically, let's just clean this up a little bit. We're going to have y square root of y over x squared cube root of x. Okay, it's kind of complicated, but you take one thing at a time and you'll do fine. Okay, so just remember these, right? The negatives and the fractions. Okay, let's see. What else do we have? I have a couple of other problems written down here. Okay, this is a good one. Okay, so let's say we want to find the equivalent of 9 to the 3/4. And you have a bunch of answers, right? Well, you have 4 answers. And let's say it's something like that. And there would be that there. And there would be that. And maybe like that. Okay, so this is the problem. We want to transform this. Okay, now based on what we know, we could say the 3 stays with the 9, so it's going to be 9 to the 3rd, and we put the square root sign over it, and we put it to the 4th root. But that's not in any of the problems. And this is a little bit hard to transform. But what we could do is transform the answers. So we know that this would transform to 9 to the 1/3, right? It's just going backwards, right? There's no number with the 9, so that's an implied 1. And the 3rd root is the denominator. Likewise, this would be 9 to the 1/4. Okay, so clearly those aren't going to work, right? Because we want 9 to the 3/4. Square root of 3 is definitely not going to be 9 to anything, so that's out. The answer has to be D. Okay, so it's a slightly more advanced problem, but that's all I've got on the exponents. Hope you enjoyed it.